application modernization, right? So this is the agenda. Starting with the problem statement. So I guess you are well aware of this. Legacy systems such as COBOL are still widely used, especially in the banking and finance sectors. There's an estimated 800 billion lines of COBOL that exists globally today. There are various challenges with COBOL applications. These codes are monolithic, very difficult to maintain. There's scarcity of developers to maintain this code. And there's a significant need of application modernization to transform these to modern day languages such as Java. So this is a very challenging problem. If you look at many of the efforts that have been done in the past, it requires humans or SMEs skilled in both COBOL and Java to actually do this transformation, right? There are some solutions that exist. These can be broadly categorized into program analysis-based solutions and LLM-based solutions, but these don't work, right? What is the issue? The program analysis-based solutions basically produce Java code that looks exactly like COBOL. It tries to mimic all the COBOL functionality, which is very unnatural, right? And therefore, you require a person with both COBOL and Java skills to maintain it instead of a person with Java skills. Now, LLM-based solutions produce good code, but the problem with them is that they cannot handle enterprise-scale applications. They have these context window limitations, and you can't definitely feed millions of lines of code, right? So what is the problem statement? Well, we want to automate translation from languages like COBOL to Java, and we want to do it at enterprise scale, right? And we want the code to look like natural, object-oriented, maintainable Java code. So what does Watson Code Assistant do? Well, it's a generative AI code assistant for modernizing mainframe applications. It's an end-to-end solution comprising of 4 components that I will talk about. Right, it's powered by IBM's own custom large language model known as the Granite 20B code model. And it has been enhanced further by IBM's application analysis capabilities. Right, and this solution is available on-prem and cloud hosted. Right, so on the cloud, we have various model processing components sitting, which eliminate the need for customer GPU investment. Okay, the components are basically, we have 4 components right now with 2 in the pipeline. So I'll talk about the 4 components. The understand component is essentially to help developers and architects understand the application. It's innovative in the sense that it combines static analysis with the AI model. It doesn't just blindly throw it at the AI model. So there's an IBM application discovery toolset, which does static analysis over the code. And what we feed to the model is the code along with the static analysis, right, to produce better results. The refactor module is to help the developer isolate or extract business logic from the COBOL programs, because you cannot just directly do the entire, translate the entire application in one shot. It's not a good practice. So it enables incremental application transformation and reduces the risk. The transform component basically combines program analysis with the large language model in order to translate from COBOL to Java, and it produces maintainable and modern Java code. And then we have the component called the validate component, which ensures the accuracy of the transformation, right? It automatically generates and executes unit tests on both the COBOL and the Java side. And our UX design has been optimized for the personas involved. LLMs have tech-driven interfaces, but we are addressing a community of developers. They are used to certain IDEs, right, that they work with. So we've developed a technology that fits into their experience. So the heart of the innovation is the large language model, which is the IBM Granite model. It's custom developed by IBM, trained on up to 4 trillion tokens coming from 116 programming languages. It has been optimized for COBOL, which is a low data resource language. We have a process for data synthesis that combines SME generated codes and scales it to very large levels to feed for training the model. And the translations are very good, and the explanations are very good that come out of the model, right? We follow trustworthy AI practices, data governance, and ethical AI principles. The model is available under the Apache 2 license. All the data preparation techniques have been open source for transparency. As a matter of fact, the IBM Granite model is ranked very high on the Foundation Model Transparency Index created by Stanford. As you can see, it's up here. And it's well above Microsoft, Meta, OpenAI, Google's, and Amazon's. Okay, in terms of uniqueness and differentiation, so there are two categories of competitors that we have, the program analysis-based solutions and the LLM-based solutions. And our solution combines both these approaches, right? So if you look at the maintainability of the code or the object-orientedness of the code, right, the program analysis-based solutions don't do very well, right? And the LLMs do well, but they are not able to handle enterprise scale applications, right? That's where we come in, and we are able to do this enterprise scale applications better because we use program analysis on the code. Again, LLMs do not produce functionally correct code. We help by adding the validate component, which helps the users to test that their code is fine, right? Is transformed correctly. Then understanding and refactor are capabilities that are not there in competing products. There is some understanding which is there in LLMs, of course, but again, we do that better because we combine program analysis information with the model. Okay, a quick demo. I have used screenshots in the interest of time to go through this demo. So first phase is the understand phase. So what we do is we can initially load the COBOL program. And as you can see, right, we can right click on any COBOL program. It shows us a menu, right? You can select generate explanation at various different levels for different personas. You can generate a guided, detailed, or a simple explanation. So here I'll just show what happens if you click on guided explanation. So here it invokes the LLM. Once the LLM comes back, it shows the explanation. This is a zoomed in view, right? You can see that the LLM has responded with a detailed, step-by-step explanation of the code. Okay, the second component is the refactor component. What this allows us to do is, so we start with the view of the application where you can see all the programs, all the databases, all the copybooks, all the resources, all the transactions, right? And then you can zoom into any one of them. Let's say you pick a program, and it allows you to basically extract a service out of that using various criteria, such as based on some conditional statement or based on a paragraph or based on a certain table or file access, right? So you may want to capture, let's say, the onboarding of a customer, right? So how do you onboard a customer? So you could do it based on some procedure or paragraph, right? So once you click on that, you get this view, and this shows all the paragraphs that are there in the code. Okay, I select onboard customer and I right click on that. I get this view, and I can, slice this into a new service, right? This particular paragraph, onboard customer. What that will do is it will pull out the onboard customer functionality into a separate view, along with all the dependencies, right? All the other paragraphs that it is calling, and present that to the user. The user can go and edit it. Finally, when the user is done, the user can again right click on that service and say generate service code. At this point of time, a full-scale COBOL program will be generated, which is extracted out and performs one particular functionality, in this case, onboarding of a customer. The next is the transform phase, where you start with the COBOL code. You can select a COBOL program. You can say, okay, I want to transform this to Java. At this point of time, in the IDE, on the left-hand side, you can see, right, all the classes have been generated. You can see one class over here. Let's see another class. This is another class, motor. And as you can see, right, it's extending from policy. So we generate hierarchical, good object-oriented code, right? And you can go and click on, methods and generate the code for the methods as shown over here. This will again, as you can see, I'll show a zoomed in view. It shows the Java code that has been generated, right? Similarly, you can generate test cases, and you can look at all the results, and you can even look at the JUnit test cases. In terms of market impact, over 80% of the banks depend on mainframe systems. 70% of global credit card transaction processing is done. App modernization is an industry expected to grow to $28 billion by 2030. So there's a very large scale scope for this, right? And in terms of social impact and sustainability, right, we have like as I said, we are ranked very high on the transparency.
Dr. Yogesh, your time is up.
Yeah.
We start with Q&A.
Sure.
Just open for question. Maybe you would like to go first.
Wonderful solution, Dr. Yogesh. So, which all places you have been able to deploy this solution and what is the result?
So this is deployed on many customer IBM mainframe customer sites, right? Of course, these are early days, so we are almost 1 year in.
Okay.
There's mixed feedback. People are very excited about it and they're willing to continue the journey for a long time. Of course, there are initial hiccups, right? Putting this large-scale solution together. The model is going to learn over time. It's not a one-time activity. COBOL resources, I mean, you don't get COBOL code for training the model very easily. So we have an initial set that we have, but it's growing, right? So over a period of time, we are addressing more and more constructs in COBOL that we want to ensure are translated properly, right? So it's an ongoing exercise, but all our customers are on board with us in the longer journey.
Okay, and what kind of productivity enhancement you have seen with this solution?
Yeah, so we did a study with Westfield, and they, which is public in the open, and they claimed that they got about 30% productivity improvement in general, and in particular for explainability, right? They got 80%, up to 80% improvement for explainability, right?
Thank you. Thank you. Good work.
Thank you, sir. Dr. Mohinder, your question, sir.
Hi, Dr. Yogesh. Nice to see that very focused and deep application. So a few questions, come clarifications. One is that you mentioned that you have used 116 different languages. Is the program or is the technique currently translating between any of those 116 languages to any other language?
Yeah. So, well, first of all, training a model with different programming languages helps, right? Not just COBOL and Java, even other languages, the model learns from the data that it gets, the constructs and all, right? Now, what we have is we have a base model that has been trained on all of this, and then we do incremental training on top of it, which in our case, because we are working on a particular product called Watson Code Assistant for Z, we do this incremental training or extended training with COBOL and Java data, right? Although the base model has been trained on all the 116 programming languages. Now, there are other use cases. So IBM has other products like Ansible and Java Code Assistant, which basically then, take the base model and fine tune it on, different data. So the base model is the same, which is trained on 116 programming languages. And each individual product then goes ahead and does their own extended training.
Okay. The next one is that along with the source codes, are you also making use of some intermediate representations like LLVM IR, or if the documentations are available, are those also being used in this modeling?
So that's a very good question. So we spent 2 years before this project trying to make LLVMs work, right? And it doesn't work successfully, right? As a research problem. I mean, when you want to come back to higher level constructs, LLVMs will never capture the kind of constructs you have in COBOL, right? They're just so complicated with shared memory accesses, right? Data structures which overlap in memory. So LLVMs, yes, we tried, it didn't work well. But instead what we saw work was definitely we provide documentation, but doing program analysis over the code and augmenting with, let's say, information about the classes, information about the variables, the type of variables, augmenting that information and passing it to the model works better, right? And that's what we have in the product right now.
Okay. The final question is that you showed the business logic extraction from a code, and also the summary possibly was there, right? So can it be done from one single file, or typically in these enterprise applications we have the entire logic distributed across multiple different code files?
Yeah. So that is work in progress. Currently, we do it on a single file, and we can select a part of a file and do it. These are like the future directions of the product, where we have to do it at the application level, because we have to, at the end of the day, the state of affair with COBOL programs today is that developers don't even know where a certain code is, right? So trying to guide the programmer to the appropriate place in the code where the code has to be modified itself is an important exercise, and that's what we are currently working on. It's very early days yet.
And along the similar lines, even for any of these codes which may access certain things which are there in the database, they may also assume something about the database schema. So is the code also able to generate, or will be able to generate at some later point of time, the schema design, the recommendation?
So we do a part of it. So look, again, the entire problem comes with the context window length. These models have limited context window length, and there's positional encoding, which messes things up, and you're not able to pay a lot of attention to things that are far away, right? It only pays attention to things that are close by. So it is a very challenging problem to provide more and more data in the prompt itself, right? It doesn't work. So what we do is, we, at least for database accesses, using program analysis, we go in and we filter out exactly what are the components that are being used by this program, and we filter out and provide a minimal set as additional information to the translation, right? That's important, because if you provide the whole thing, it's the model is going to get lost. So that's why, that's our main differentiator with these LLM-based Gen AI techniques, that, just applying models blindly is not going to work. You've got to back it up with program analysis.
Thank you very much. I'm done.
Thanks.
Thank you, sir. Dr. B. Yeah, ma'am. Please.
Hi, Dr. Yogesh. It's really interesting work. I just follow up with Dr. Manudra. Sorry, I may not pronounce your name properly. Follow up with his question that you mentioned, that the program analysis-based techniques are really important. So how much of that are integrated into your language model learning, and how do you actually do the integration?
Yeah, it's really, really large scale. I would say that the model is a part of the component. It's of course the heart of the component, but there's an equal amount of program analysis that goes around it. You cannot, we've seen it, right? I tried to present it in the comparison. Just applying program analysis alone, which people have done for years, or just applying LLM, which people are doing today, is not going to work. So I would say that almost about 40 to 50% of our product is based on program analysis, right?
Right.
I'll take a simple example: class generation, right? If you look, context window is a problem. If you pass two different modules to the LLM and ask it to generate the code, it will generate different data structures for the same thing, right?
So, yeah, exactly.
So we do the entire object-oriented design ourselves using program analysis, using rule-based techniques, because it's well-established practices how certain COBOL constructions be translated to Java. And then this information, what is the class design we expect the model to adhere to, is what we provide to the model in the context, and ask it to produce Java code that adheres to that class design.
Yeah, so your language models are going to be reasonably small, right? It wouldn't be a large language model per se that has all this redundant information that are not related to programming language translation.
No, currently they're
right?
So one of the challenges we have is integrating the explanation model and the transform.
Right. Okay.
Because these are two different things. Okay. So and we can't deploy two models at the customer sites, right? That's a lot of GPU resources.
Yeah.
So on.
Sure.
So we still need a large language model which can perform different tasks. And our customers are not just working on COBOL; they're working on. So IBM has products around JCL, around PL1. So there are multiple programming languages for which they do explanation and translation. So one model doesn't fit all. So we still need a large language model, and we again then tune it up for specific tasks for special use cases.
Thanks a lot for sharing this. Yeah, that's the end of my question.
Thank you. Dr. Nair?
Yeah. you mentioned that you are converting COBOL to Java. I mean, in fact, when I saw the Java code, I was thrown back in time. Nice to hear COBOL code after such a long time, and good to know that people are really working on how to convert it to. So I was wondering that have you ever thought of doing the other way around from Java to COBOL? It's just an out of the way question.
Yeah, no. So there are still, certain things in mainframe, certain components in mainframe which COBOL does so much better than Java, right? So that is definitely an interesting use case. We are not there yet, frankly. What we are currently trying to address instead is code generation of COBOL, right? Where the users explains in English what they want to do, and we directly generate the COBOL code for that. It's an important use case because we have customers on mainframe who are going to continue to use COBOL, right? So that's something we're looking at, but again, these are early
Yeah.
days for that.
So how many customers are there as such who would like to convert from COBOL to Java?
So that's confidential numbers, sorry, but it's
Well,
in,
roughly, I mean, I'm just asking
yeah,
an approximate.
it's about thousands, yeah, it's in
Thousands.
thousands. Yeah.
Okay, all of them do want to convert. Is it right?
Everybody wants to, but they're
They're not
careful.
sure about it.
They're careful about it because there have been past efforts, right? Commonwealth Bank and all. People have failed in doing this. It's a huge investment, spending hundreds of millions of dollars over 5 years, 10 years. And, it has to be done the right way. It can't be just, there's no fixed template that you can do it in a particular way.
So when you're converting COBOL to Java, how much of human intervention is required?
Yeah, so it's a code assistant. I showed you some of the menu, right? I ran through the demo. So definitely, the user guides all the stuff that's happening. And there is a lot of stuff that I couldn't show you due to limitation of time. But one important part is that after the code is generated, we expect the user to again have to, spend about 30%. So it's a time reduction game. We expect the productivity to increase by about 70%, right? That's our end goal. So again, we are on the journey, but our end goal is to improve productivity by about 70%. The developer will have to go in and modify the code after it's generated. There are certain things that are not supported in Java, which are there on mainframes and so on, right? Other things. So the user has to step in. At the end of the day, it's a code assistant.
So have you ever tried converting? I mean, you run the COBOL program, you get the output. So if you have the output, then can you not use the output to generate Java code? Have you thought about that kind of a thing?
Sorry, could you repeat, please?
See, you run the COBOL program, you have the outputs, right? When you run the COBOL program, you have the outputs.
Yeah.
So what you want right now is a Java program that actually creates the same outputs. Have you thought of that kind of a paradigm?
Yeah. So this is again, something that I think is well studied in research. I know there's a lot of research going on around this area, providing abstract syntax trees, providing grammars, providing input outputs, right? But I think people have shown it on some research benchmarks, but this doesn't work for enterprise applications. The enterprise applications are so complex that it's not, we don't get meaningful results when we augment them with input output.
Okay.
But we do provide a validate component, so that once the user is done with all the translation and his edits on top of it, he can run the validate component to ensure that it generates test cases using byte part testing and ensures that all paths are covered and all generates test cases accordingly.
So how many migrations have you done so far?
Yeah, again, sorry, that's a confidential number.
Okay.
I would say
There are.
Yeah, I would say
I don't want the number. I just want an approximation.
It's in tens. Yeah.
So they have actually migrated from COBOL to.
No. They are on the journey. Even one project spans about minimum of 3 years. That's the minimum span for one project. As I said, this is not a turnkey solution. The developers have to be involved. They
Yes.
have to validate the object-oriented design. Once the code is generated, we expect them to. They have to go fix a few things, and only then they can run the validate component. Of course, then they run the validate, and of course, customers don't just replace one solution with another. They go in a phased manner of replacing one component as backup and slowly, upgrading their systems.
Okay.
Thank
Thank
you.
you so much from my
And
side.
jurors, Dr. Yogesh, the time is up. I request you to please copy the link which we have shared in the chat box before you leave the session. Thank
Okay.
you.